Hello students, this is part 1 video of halogens, and in this video you are going to learn about general characteristics of halogens. It means here you are going to learn about the color and state of halogen, melting point and boiling point, density, about the density of the halogens. Especially I am going to explain about the order, which you will require in your exam. Atomic radius, the order of atomic radius, electronegativity, and electron affinity order. The element fluorine, chlorine, bromine, and iodine, they are collectively known as halogens, or they are commonly known as halogens. And the element astatine and tennessine, they also belong to the same group in the periodic table in which these elements are present. And these are the symbol of these respective elements. Now, what is the meaning of halogen actually? So halogen, this word is derived from Greek words, and halogen means salt producer. It means the element like fluorine, chlorine, bromine, and iodine, they generally form salt. For example, NaCl, right? NaCl, this is one salt which we use in our daily life. Similarly, NaBr or KBr, Ki, similarly NaF, sodium fluoride. So these are some example of salt. So halogen, when they react with active metals, or other metal, they give salt. So they are called salt producer. Positions of halogen in periodic table. In the periodic table, halogens, they are present in group 17. As you can see here, fluorine, chlorine, bromine, iodine, astatine, and tennessine. They are present in group 17 of the modern periodic table. Now let me teach you one trick to remember atomic number of these halogen atoms. Okay. So this is the picture that I have cropped from the IUPAC table, periodic table. Now you can see here a difference between the atomic number of these two elements, that is 8. Here also 8, and here 18, and here 18, and here 32, and here 32. Okay, so it means here the difference is 8, here 18, here also 18, and here 32, and here 32. So just remember this pattern. Okay, 8, 18, 18, 32, 32. So atomic number of fluorine is 9, right? So just add there fluorine, chlorine, bromine, iodine, astatine, and tennessine. Now you can easily find the atomic number of the remaining elements by using this pattern: 8, 18, 18, 32, 32. So go on adding. So 9 plus 8, 17, and 17 plus 18, 35, right? 17 plus 18, 35. 35 plus again 18, that is 53. Again 53 plus 32, that is 85. And again 85 plus 32, that is 117. So by using this trick, you can easily find the atomic number of these all atoms. Okay, so I hope you like this. Color and state of the halogens. Fluorine, it exists in gaseous state at room temperature. In this picture you can see a gas ampoule that contains fluorine gas, and you can see here it is yellowish in color, right? So fluorine is a yellowish gas. It means we can say fluorine is a yellowish gas at room temperature. It is very, very toxic, very poisonous. Okay. Chlorine also exists in gaseous state at room temperature, and it is greenish yellow gas. As you can see in the picture, it is greenish yellow gas. It is also very, very poisonous, very toxic to our body and even to environment. Bromine is a reddish brown liquid. As you can see in the picture, bromine is a reddish brown liquid. Iodine is solid at room temperature. It appears violet black in color, and when we increase the temperature slightly, it appears purple black in color. The fumes, they are also purple black in color. So let me revise once again. Fluorine, it is yellowish gas at room temperature. Chlorine, it is greenish yellow gas in room temperature. Bromine, it is reddish brown liquid at room temperature. Iodine, it is purple black or violet black solid at room temperature. And regarding acetine, it is extremely radioactive. It is expected to be dark solid. Okay. And regarding tennessine, it is synthetic chemical. Not much has been known about this chemical so far, but it is also expected to be dark solid at room temperature. Melting point and boiling point. With increase in atomic size of the halogen atoms, the melting point and boiling point also goes on increasing. It is because of increase in van der Waals force when the size increases. Okay, so we can write the order of melting point and boiling point. Fluorine, chlorine, bromine, iodine. Okay, so this is the order of melting point and boiling point for the halogen. So you can easily predict this, okay, since you know that fluorine exists in gaseous state at room temperature, bromine in liquid state at room temperature, and iodine in solid state at room temperature, right? Now regarding density, so in a similar way, the density of these halogen atoms also goes on increasing from fluorine to iodine. So fluorine, chlorine, bromine, iodine. So this is the order of density for halogens. Regarding atomic radius, the order will be fluorine, chlorine, bromine, and iodine. Regarding ionic radius, the order will be fluorine minus, chlorine minus, bromine minus, iodine minus. So it shows halide ions. Okay, these are the halide ions, and I have kept here according to their order of the ionic radius. The order of electronegativity for the halogen atom will be fluorine, chlorine, bromine, iodine. So it shows that fluorine has the highest tendency to pull the electrons from the covalent bond in the molecule, right? So as the size goes on decreasing, the electronegativity value goes on increasing. Now regarding the order of electron affinity, the expected order according to the size, the expected order is fluorine, chlorine, bromine, and iodine. Okay, but in reality, it is observed that the electron affinity values follows the order chlorine, fluorine, bromine, and iodine. So since fluorine is very small in size, there will be electron-electron repulsion. Because of this repulsive energy or repulsive force, the electron affinity will be low for fluorine than for the chlorine. So I hope you understand. This is one important question from this topic. So see the question. The correct order of electron affinity of halogens is. So see the options and choose the correct answer. You try this by yourself, okay? Question number 2. Which is the strongest oxidizing agent? So among these four options, which is the strongest oxidizing agent? So the right answer is fluorine. Right answer is fluorine. Fluorine has highest value of standard reduction potential. Standard reduction potential. Reduction potential. It means it has high ability to get reduced. It has very high ability to get reduced. It means it will oxidize other and itself gets reduced. So it will reduce itself but oxidize other. So it is the strongest oxidizing agent. It has highest value of standard reduction potential it reduces itself but oxidizes other elements. So right answer is fluorine. Question number 3. Which halogen do not show positive oxidation state? So among these 4 options, right answer is again fluorine. Fluorine shows only 2 oxidation state. They are fluorine 0 and -1. 0 and -1, but do not show positive oxidation state. Okay, do not show positive oxidation state. While other elements or other halogen atom, they show positive oxidation state also. -1, +1, +5, +7. Okay, they show other oxidation state also. Thank you for watching.